Hello Internet, welcome back to DataSphere. Today we're going to be taking our connections, our TCP listener and our TCP client that we put together yesterday, and we're going to actually be making it do things. So we got it sending messages. If I click this button, we send a hello world of sockets message out to our client, and then it does something with it. Problem is it doesn't do something with it right now. It just sort of sits. So what we're going to do is there's going to be two parts to this. First, we're going to stop all of these particles from emitting. So I'm going to stop that quickly and open up our DataSphere emitter. And I'm just going to take this out. So this entire update and start, we can just delete those. Then what we're going to do is we are going to make this create data point private. And finally, we are going to create a public data point that is going to create something. So we're going to want a public void emit data, I guess is a good word for it. And so this is going to be our message that we're going to receive. So all we need is just a color and then a right ascension and a declination. I chose right ascension and declination because I was thinking astronomy. I kind of changed it from pitch and yaw because that doesn't really make as much sense. So this is based off of right ascension is if you take the equator. So if you take, not equator, sorry, if you take like Greenwich, I should know that, the date line, if you take that, what this is it's a measurement from that around the circle. So it's going to be 360 degrees. We've cut it down to 0 to 1. So 1 will be all the way around and 0 will be just the start. And then 0.5 will be on the other opposite side. And then we added declination, which is the measurement of how far up or down it is. In astronomy, this would measure how far above the equator the sun is normally. We're not using it for that. We're using it for this. I probably should change these to like latitude and longitude. That would have made sense, wouldn't it? Oops, we didn't do that. So we're going to have to actually translate these. But that doesn't matter for now. What we do need is we need a data point view model. And this is going to be our data point, like so. And all we're going to do is create a data point with that view model. And we're going to want to pass in a color there, like so. And then we can swap out this whole function. We'll lose some of that cool color madness, but we'll actually be able to control the color now. So we've got the color gone, declination, and right ascension. So we need our data point to have all of that. So let's just assume it does. And then our data point of declination. And oh, that was wrong. And then we'll do a color as well. And so what these are going to do is not that. What this is going to do is it's going to be, we're going to send a message to every object on this object when our server reads something. So this is the first point that we're going to do. The next bit is going to be the fun bit. And that's where we go into this name server. And we're actually going to look for this listen for message. And then we are going to read it. So this is going to be where we have read our data. Where is it? Received to upper. We encode our message that we're going to send back, and we send it back. None of this really matters to us right now. We don't really care about it. So up here though, what we want to do is we want to send a message called data. That's not what I want to do. I want to send a message called emit data. Let's do data received actually. And we're going to pass in a data point view model. So this is going to be our data. And so we want a var data is equal to a new data point view model like so. That's not going to work because we have two things called data. We'll call it our view model instead. This is just temporary just so we get this working. And then we're going to eventually need a data point view model created as well that we can actually use to read this stuff. But we don't have that yet. But what does matter is this send message is going to send a data received message. So it's going to call data received, the data received message on every component attached to this object. So if we name this data received, it's going to get called with that argument. And then all we have to do in here is take this data and parse it into a data point view model. And then we can pass it along into our data received object and it should emit a point. Or at least that's the theory. We'll see how well that works. But what we can do now is actually create that. So if I open Unity quick, we can create our view model. I'm actually going to create a view models folder. And that's just for clarity's sake, really. So we'll do data point view model. If we create this, we can pretty much get rid of everything. So that's gone, that's gone. And then we just need 3 getters and setters. We need a color, which we got there. And then we need a write ascension, which we have there without a type because I am going too fast. And then we need the declination as well. So do that. And now this should be very happy because it has all the points it needs. Eventually we'll actually name these properly. We're just going to get this working and then we can, I like to get things running and then I like to refactor things after we've done like the simple solution, the one that we can understand and kind of walk through. It doesn't make a lot of sense to add a bunch of extra code here now while we're still working things through, because if we change our mind later, it's all wasted time and then what was the point? So that's what we're gonna do. We're just gonna make stuff up. So our write ascension can be between 0 and 1, which means random dot value, which isn't going to work because we have 2 randoms. So we're going to have to explicitly reference it. The reason this is required instead of normally doing this is because we included system in this file. And that means that we need to actually explicitly say which random we're referring to because there are 2 namespaces with a random object in them. So we want the one from Unity, and we are going to do one more thing. Do a declination equal to the Unity engine's random.range, and we're going to do between -1.f and 1f. So this is almost identical to what we had. The only difference is now I'm going to hard code in a color. And we're only having this because we don't have parsing done yet. Eventually we will, we just aren't that far. So for now we'll plug in a cyan color. And what this is going to do is every time we receive a message, it's going to draw a random cyan dot, or it's going to emit a random cyan particle into our particle system. So we should be able to plug into this, start it. And then as I click this, ooh, that's not right. They have broken things. Yep. I broke them. Okay. So that didn't work. One sec while I fix this. Alright, so I've tried this a few times now, and every single time I click this button, it is locking up Unity, which makes me think we're doing something wrong. And it's probably what I did. So we're gonna dig into this a little bit and see what's going on. we have our view model that we're creating of a new data point that wants us to use an object initializer. We don't really care about that. We send a message to data received. You know, I've got a better idea. Let's actually walk through this and see where we get, because I'm kind of curious. So if I attach to Unity, we have a breakpoint. Once it figures out what it's doing, we have a breakpoint here at the send message. I'm actually going to stick this up here, right where we added our code. So we should be able to create this, walk through here, hit this, and then everything should go. So we start this now. I should be able to click this button. Ooh. A blocking operation was interrupted by a call to WSA. Cancel blocking call. I wonder if we haven't been closing our sockets correctly. Because what this is doing is it's opening up a port that we're listening on. It opens up port 8080. So I'm wondering if we may have already, when we've crashed Unity a few times, I'm wondering if it's still open. So how do we fix that? I don't know. If we restart, we should get the same error. Yeah. Okay. Let me investigate this and we'll see what happens, because I'm confused. I'm not sure what's going on. I'm pretty sure our socket has taken over our port and we're stuck, but I think we can fix it. So let me see what I can do and then we'll get back to this. Oh, okay. So they're saying that it's probably a threading issue, and I think I know what the problem is. If you look here, we're sending a message, but we're on a separate thread. Though I don't know why that would stop, because we haven't hit this code yet. But regardless, I'm going to actually take this out for now. And then we're going to run this again and see what happens. I'm guessing it's going to work. Yes. Okay. So we can actually fix this. It's a little bit harder, but we can do it. What we're going to do is we're going to make a private, let's actually just do a queue. Queues work of a data point view model. And we are going to stick in just data points queue. So then in our update, what we want to do is for each point in our data points queue, let's take, wrong button. Let's take off all of them. So we've got our points created. We can still keep this here. Where were we? Up here. So we can still create it, but what we want to do is we actually want to send it into this queue. So we want to do a data points queue, and we want to enqueue our view model into it. And so all this is going to do is it's just going to stick things onto the end of that queue, and then when we get into our update, we're going to pull everything back off of it. And then we are going to do our data points queue dot clear. Now the problem with this is it's not going to work. We are going to need some other queue. So we could use the issue. Well, okay, let's walk back. So the issue we're going to run into is this is happening on a separate thread. And so while this code looks right, it isn't. We're going to have a bunch of threading issues because it's possible that while we're iterating over this, our thread comes in and adds some more. Or after we've read through this, it's possible that we add another one and then immediately clear it. We don't want either of those situations to happen, and both of them are possible with this. So we have to fix it. The fix is a few different ways. It's another threading problem. It's kind of a producer-consumer issue, which is another classic concurrent programming thing. We've got our consumer here. That's just reading in messages off of a queue. And we've got a producer here that is producing a bunch of messages and putting it onto a queue. It sounds weird that our server that's listening for messages is our producer, but that's just the way the problem is phrased. So things that are producing messages to be consumed are producers. So what we need to do is either synchronize this somehow and make sure that it's totally safe, or do something else fancy. I think there are collections, no, threading. Is there not a, sorry, I'm looking for a specific type of queue. Doesn't look like it has it. It must be in a different library. That's fine. We won't need it. Actually, we kind of want it, but anyway, we don't have it. So there are concurrent locking queues that will asynchronously read from this queue, so we can iterate over this and then clear it and know that there's nothing there. The issue is we can't do that. So since we're doing that, do we only want, so we could limit this to only do a certain number of things per whatever, but I don't think we want to do that. Instead, let's just make this a lock on our queue lock. And so there is no queue lock yet, and we're getting to that. But the idea here is we're just going to create a lock that's going to be a really simple yes, it's only going to allow one thing to enter that lock at a time. And so by locking here and here, what did we call it? We called it our data lock, I believe. No, that's not what we called it. Queue lock. And so what this is doing is it's saying, here is this object. We're going to have to create an object for this. Every object is going to have a counter or some sort of async thing. I forget exactly what it's called, but what happens here is this locks our queue. It doesn't lock our queue. We're not going to lock our queue. We're going to lock something else. Just a general object called our queue lock, which is literally just an object. What goes on here? It's being silly. There we go. No? Don't like that? Okay, sorry. We were getting into some more namespace issues. Unity has object defined apparently, and that was causing weird things. So getting back to this, what's happening is our lock is just I believe it's called it's a reentrant lock, which means that a same thread can lock multiple times. And so it's a little bit different than a semaphore in that way, because since it's reentrant, it doesn't necessarily keep track of a counter. It's actually going to say this thread has a lock on it. And so a thread actually owns this object for a certain amount of time. And the important part is only the object that owns the lock is able to execute code within it. And so what happens is when we get here, we're going to acquire a lock. Then we're going to remove all of our objects from our queue. And then we're going to we're going to clear it, and then we're going to do some more stuff. So, do we want to do this? No. The answer is no. But we're going to leave it here for now. This is, again, slow, and we can actually speed this up. Actually, screw it. Let's speed it up now. So I'm going to move this out again, and I'm actually going to create a new queue. Data point view model queue, and call it our temp queue. And so we're going to assign our data points queue to our temp queue, and then we're going to create a new queue from our data points queue. And so what this is doing is it's kind of swapping them, and then we're going to iterate over our temp queue here, and then we don't need to clear it because it's going to be removed as soon as we exit this. And what this gets us is it speeds this part up, this locked part, because we still need that lock there. But the important part is that now this is relatively quick, because instead of having to iterate over every message we've received, we've just taken them all out, and then we've replaced it, and then our TCP listener can continue its stuff. So now that we have that, what do we do? I think that's good, actually, because we're iterating over this. Yeah, I think we've got it. So all we're doing is we're locking when we're doing anything with that one queue. Whenever we touch our data points queue, we want to make sure that only one thread is touching it. So we're going to have these locks all around that queue. And we do. So I think we should be good. The only other thing we need is we need to actually initialize this to a new queue. And then every single frame, that's going to be cycled out, which is also fairly slow, but we can speed that up as well by just cycling between two separate queues and just clearing them after every frame. I don't think there's that much overhead, honestly, so we probably won't do that, at least for now. I think we should be good. So let's see if this works. And remember, just to go back, the reason we're doing all of this is because we cannot send messages in Unity that isn't on our main game thread. And so that whole queue stuff got all of our messages off of our TCP listener thread and stuck it back into our main update loop. So now the idea is if we click this button, we should emit particles, but I don't see that happening. So let's walk back here. I'm going to stick that there. And another one here. And let's figure out what's going on, because I'm not entirely sure. And so we'll start. We should hit a breakpoint as soon as I hit the button. Or it won't close our socket. And it isn't closing our socket. For what reason? Oh. Is Visual Studio's debugger getting in the way? Is that our problem? Can we not run Visual Studio's debugger because it interferes with our sockets? Well then, that's fun. Found out why it's not working. So this is supposed to be on 9123 because the ports have to match or this won't work. And so our server was on 9123 and our client was on 9001. So they were missing each other and nothing was happening. Now if I click it, still nothing. Wasn't exactly what I expected. Oh, we crashed it again. No. Wait. Hold on. We didn't crash it. We just got very slow suddenly. get value can only be called from the main thread. I wonder what that is. What's throwing this? Something. Unity's being quite slow. I'm pretty sure I caused this. So, once it starts responding again, we can actually figure out what's throwing that error and also try to figure out why it's so dang slow. Because that's kind of weird. And I don't much like it. And I kind of broke it. Kind of broke it a lot. All right. I think this calls for a restart. Again. Great. Okay. So we're back and things are still broken. This is becoming a running trend for this project. I'm not sure I like it. I think our best way for figuring issues out is a whole bunch of logs. So we are going to read message. There we go. So we're just gonna log out every time we read a new message. And what else are we gonna do? Listen for messages. That's an infinite loop. Except we do not restart when we have socket exceptions. One other thing I want to check quick. TCP listener. It doesn't inherit anything. That is unfortunate. I was kind of hoping it inherited a disposable thing, because then we could get rid of this server stop and this client close. Actually, we still may be able to get rid of the client bit. Yes. Okay. So we're going to go through and clean up some of this stuff. And then we're going to see if we can't get it working again. The way we're going to clean it up is we're actually going to stick it in a using, like so. And then we're just going to add a bracket here. And we are going to close it again. Now that looks silly, but what this does is when you declare a using and then a disposable object, when this leaves scope, it will dispose of this object for you, which means it's going to call the dispose method, I believe is what it's called. It's going to invoke that interface, which is going to clean it up, which is going to call your close. So if you're working with a lot of streams like we are, this is a good way to handle that. So I wonder if we should close this as well. I think that would make sense. But then why aren't they? That's kind of confusing. We'll leave it for now. I may come back and do that, but I just kind of wanted to get that out of the way so we know where our client is getting disposed of. So even if we throw an exception somewhere up here, we don't miss that close bit that we would have if we didn't have it. So now we have that. We have our while true. What else do we need to do? I feel like that's it, but we're obviously things are breaking. So I'm gonna remove these breakpoints. We can't debug, unfortunately, which is kind of an annoying and weird issue that you can't use sockets when you're debugging with Visual Studio. That seems like a design flaw, but I think this should work. Why isn't it working? All right, let's try it one more time. And if it doesn't work, cool. Get value can only be called from the main thread. What's throwing that? Random is throwing that. Awesome. That is fantastic. That is precisely what I want. Not really, but it's close enough. So we aren't going to use random. We're going to use two just basic numbers. I'd use something else, but it doesn't really matter. We just need to make sure that our point shows up. And there it did. So cool. That happened and we got our point. Awesome. You probably didn't see that, so I'm going to pause this time. And we actually get our little particle dot. So this means we're actually receiving our message, which is fantastic. It means things are working. It took forever, but it means things are working. So now what we can do is we can actually JSON encode this, which is going to mean this is going to look, we don't need to do it here. Yep, that made total sense. I'm glad you followed that. Good. Glad we're on the same page. I'm going to do a JSON utility, and then from JSON, I'm going to create a new data point. So with that, we're going to pass in our data. That's going to create our view model, and we get this. What this is going to do is it's going to parse JSON data, which is, what's it? JavaScript encoded object notation? JavaScript object notation? Something like that. That's probably wrong. Actually, it almost certainly is. Point is, what we're doing is we're going to accept JSON messages that match this template. So you pass in a color, right ascension, and a declination. I'm actually thinking we may want to drop this color for our own encoding for color, but we'll leave that for now. Pretty sure that's going to break it. Screw it. We'll leave it, and then when we get errors, we'll fix them. So we have that. What we can do now is, since we're actually able to pass things, I can select this button where we're sending our message, and we're going to want to make this big so I can actually type. And we are going to pass in a right. What was it? Shoot. Can't remember my own things. Right ascension. I really am starting to not like that name. And then all you have to do is give it a value. We'll give it 0 for now. And then a comma. And then our declination, which will also be 0. And then our color, which is going to actually be a complex object with R equal to 1, G equal to 0, and B equal to 0 as well. And I believe there's an A component in there. So let's add that. We'll make it 1, so it's fully opaque, and it's going to be red. So we have that. If I just close that now, theoretically that's a properly formatted JSON. I could be very wrong there, but it looks correct. So what we should be able to do is start this and then do that, and we get a blue dot. Wasn't expecting blue. And I wasn't expecting it in random places. Huh. That's odd. Why would that happen? Did I do something silly? I'm in the wrong project. Yes. The answer is yes. Yep. I did something silly. Why is this here? This doesn't need to be here. Okay, we'll delete that. and actually use the points that we pass in, because that is what we were supposed to be doing. And then we'll stop this, restart, and we get a single red point up here, which seems wrong. I feel like that's not right. Wait, I think I know what's going on. Our particle system is rotated. There we go. So it's working. The reason the rotation was causing problems is because it's in local space, but now everything is good. Need to do that in actual edit mode, but we're able to actually pass in our JSON encoded object, and the best part is we can pass in color, declination, right ascension, and it actually gets rendered to the screen properly, which is all cool, which means that I can just start this on port 9001. We're going to want to remember that. So we have this. If I jump back here then to our DataSphere plugins project, this is a new project that I've been working on. Haven't really been working on it. The only thing I did is I copied our client code. And so there's two projects. There is the common, which is going to be used in the plugins, and then there is a random generator example, which is just going to generate random points and send them down the stream, and then our other thing is going to draw them. So what we need to do is first off, add references to our DataSphere client, like so. And then, now that we have that, I should actually mention quickly, these are .NET Core projects. And the reason they're .NET Core is this way they can run on Linux and Mac and anywhere else, which is going to mean these should be cross-platform. Haven't really confirmed that, but they should be. There shouldn't be anything that's preventing this from running on a Mac. So, now that we have that, we need to update this. The problem is our .NET Core projects are on a newer version of .NET, which does not have the same objects as current .NET or Unity.NET. I shouldn't call Unity's .NET current. This is the current version. Unity's behind. Right. So what we need to do is our TCP client doesn't work like this anymore. It actually has to be, I'm going to put it in a using, and then I'm going to, not do that. Sorry, I broke everything. Okay, so we're not going to do that. We're going to bring that here and remove that client close because we're doing our disposable thing again. And then we actually need to connect our client. And we're going to connect over our server and our port. We could use an IP address thing now, which is an option, but I'm going to keep it as close as we can keep it. The only difference now is that we need to await this connection, which means this has to be async, which means we should call this connect async, which means this needs to change. And all the changes kind of bubble up. So this becomes async as well. Yeah. We return a task, send message to server, async. Do I want to do that? Do I want it fully async? Yes. Yes, I do. Okay. So tasks are the new version of threading. Unity doesn't have tasks because Unity's behind. Tasks came around in, I believe, Unity or C#4. And so what they do is they're like a lighter weight thread. Threads are kind of your workers. They're capable of doing a lot of things. Tasks are lower level. They're designed as, I need to do this one thing, and then I want it to go away. And in this case, what we want to do is we want to connect to a client, send a message, and then disconnect, and that's it. And it's gone, forgotten, everything else. So async task. Sorry, I'm thinking about a ton of things now. What this is this is going to be a private method that is async, which means it's going to run asynchronously. So execution of our program is not going to be stopped by this call. It's going to return a task that represents that async thing that's happening. And then we're going to hit this connect async, or this is actually going to be our call it. And we're going to await the completion of that. Actually, we can just return. No, we can't. What am I doing? I need to stop making things up as I go. That doesn't make sense. This does. So the async await came into being in .NET 4.5, I think. And what it is it's a way of writing asynchronous programs. So you can say this function runs asynchronously, and all functions that run asynchronously must return a task. It's best form not to just return an empty task, because then it kind of makes this valid, even if it really isn't. So what you want to do is you want to usually return something. For now, we're going to leave it off, and that's mostly just because at this point we don't really need it. But now that we have that, what this is going to do is it's going to say wait for this to finish, and then finish everything else in this method. There isn't anything else in the method, so it's just going to go on its way. So this method is also async. And so best form is to name anything that is asynchronous as async at the end. And that's just so everybody who uses it knows that it is going to run asynchronously. And I think .NET pretty much follows the standard as far as I've seen. And most other libraries are going to follow it as well. So if you're making your own library, anything that's async, just add async to the end, and that way everybody knows. So all this does is it just wraps our connect async in a fun little connection and then sends off a message. So how this works is you just spin up a server, or rather spin up a client with a server and a port, and then you say, I want to send a message asynchronously. It will do it, and then it will return. So that's all you need to do. What we need in here then is we just need a datasphere client, which will just be our client, new datasphere. We're going to do 127.0.0.1, and I believe it was port 9001. And it isn't finding it because we didn't add our using. There we go. What's going on here? Can't resolve it. Oh, do I need to build? I may need to build. One sec. So while that's going, what we need to do now is we need to more or less copy our, oh, it's broke. And that's because this doesn't compile, because this is wrong. Our stream needs to be in a using, which means we should probably take our bit from Unity and actually move that in here too. But for now, I'm going to ignore that. I'll do that on my own time. We're going to be doing this again in our listener in Unity's side, but for now we can just do this. So all this is doing is it's going to open a stream and close it, and then that should work now. So if I go back to our program, or rather try to compile this, it should compile now. And hopefully our types get exposed here. And then we can see this and we can use it. And then all we want to do is just open up probably just open up a really simple connection. And then I think we'll just do like a quick little spiral, which we can do by just incrementing both of our floating points at different values. And that will just do that around our particle system. And then if we just wrap them, it should work, I think. We'll have to play around with it and see what happens, but it is causing all sorts of issues. Can't resolve datasphere client. but it's right there. That's kind of weird. .NET Standard Library. Okay, that's kind of odd. I'm going to check our project JSON. I think it may be .NET Core 5. And yeah, so we have two different frameworks we're using. This is on the .NET Core App 1.0. And this is on our .NET Standard 1.6. Which I don't know which one we want to use. I'm really confused. So it's been a while since I've used .NET Core because I've been stuck doing other things. So how do we fix this? I don't know. So best way, trial and error. Well, actually the best way is probably Google, but we're not going to do that because that would be too easy. So if we just copy in the .NET Core app, what happens? Does not exist in common. Yes, it does. Let me show you. I'm pretty sure what I did is wrong. Almost positive. Like that much positive. That's not almost. This much. That much positive. I did stuff wrong. Yep. I'm doing things that I shouldn't be doing. Let's redo that, undo that. That'll restore everything. It's back. .NET Core app. Is it because they're on different versions? Like, I feel like we shouldn't be on the standard, because so one of the things that .NET Core changed is that they pretty much tore apart the common libraries and kind of split them up into their own little tiny pieces. So you don't just get .NET, you get, .NET's threading library and .NET's file IO library and all of those other things. And so it made everything smaller, but it totally destroyed everything. But we're not getting any. We don't get any issues, and we're both including .NET Standard Lib. So I don't think that's wrong. I'm pretty sure I'm doing this right. Can be safely removed. Oh yeah? Oh. Yeah. What? Hold on, something weird is happening. I'm pretty sure this is actually working. It's just not working. Maybe it's a problem with ReSharper. Let's see. So I should be able to just start this. So if I can, let's do a console write line of hello world and a console read line just so we don't exit immediately. And let's start this project and see what happens. Now, if it's actually working, we should see hello world. If it's not, then it should crash. So I think I'm going to go with ReSharper's freaking out a little bit and not able to find references for some reason. So that error that we're getting isn't actually an error, which isn't confusing at all, but it's the way things are. So now that we have that, what we want is we want a float of our rate ascension which we'll set equal to negative or 0 actually, and a float of our declination, and we'll set that equal to -1. So it'll start at the very bottom center, and then it will spin it around. And so, while true, that's the easiest way to do this. Then we can just stop it whenever we feel like. We should be able to just send a ton of messages, which means we are going to want a task to do this because we're going to want to run an async, which means what's the best way to do this? I don't know. Well, first off, we're also going to want to store the total change in time, and which means we're going to have to calculate this ourselves, which is going to be nanos, and we should be able to do, I don't remember how to do this. Okay, that's not right. Date time. So you're not supposed to use date time for small changes. It works all right for macro changes for like seconds or even like microseconds, but we're going to be talking about a lot of messages, like thousands of messages a second, which means we're going to loop through this 1,000 times a second. So we need something a little bit faster, which is not that. It's going to be, I don't think it's the console. Environment? So I'm kind of guessing in the dark because I did not do any research before this, and that was a mistake. Tick count, no. None of this. One sec, I'm gonna go look up what I need, and then I will be right back. That's what we wanted. Duh. Okay. What we wanted was a stopwatch. I knew we wanted a stopwatch. Why didn't I use a stopwatch? Okay. So we're going to create a new stopwatch. And this is actually going to be able to measure timings for things. So we're going to do a stopwatch dot probably start. Actually, we want stopwatch start out here. And then at the very end of this, we want to stopwatch restart, which is going to reset our stopwatch and keep it going, but we're going to have our stopwatch always be back at 0 after our frame is done. Then what we can do is make 2 more variables. We'll call it the write ascension speed, set it equal to like 10, and we'll call it our float of our declination. We'll set that equal to declination speed, set that equal to like 2. So it'll rotate around a bunch, but it will slowly kind of go up. Probably set that to 0.5 actually. And since theoretically this is going to be per second, it should take 4 seconds for it to go from bottom to top, and that's because it's a range of 2, from -1 to 1. So that means every second it's going to go around that 10 times, which is pretty fast, but I think we should be good. So let's take our write ascension, and we're going to increment that by our stopwatch dot elapsed milliseconds, elapsed ticks, something. Elapsed, I don't know what I'm doing. Actually, let's just use total seconds and just change all of these to doubles. So I don't think we'll have any conversion issues because even though we're using doubles here and floats on the other side, there's a JSON conversion in between that, and I think that will catch it. And it will, well, we'll find out because we'll get parsing errors if it doesn't work, but should work. And then we can do our declination speed plus equals our stopwatch, and we'll do the elapsed dot total seconds. What am I doing? I'm thinking about this way too hard. And I am also using the wrong thing. We want to multiply here by our declination speed and multiply it by our write ascension speed, and then set our write ascension and our declination like so. So it's just going to add up there. Then I'm going to actually pull this back and stick a restart there. And then right before it, we're going to do a elapsed, and we're going to actually save out the stopwatch elapsed. And this way, this is relatively slow, so we're not missing too much. And so that we should just be able to actually more accurately capture this. Because the problem we were going to have is we were going to have our restart right at the bottom. So we're going to restart, and then we're going to capture our time. And there wasn't going to be any time, so all of the actual slow stuff wasn't actually going to be considered in the time that it took, so it wouldn't have really worked. So now that we have that, we can take all of that, put everything there. Now, write ascension and declination are a thing. So if our write ascension is greater than 0 or greater than 1, or rather, while our write ascension is greater than 1, then we want to subtract 1 from it. And so the reason we're doing a while is, say we get some massive lag, like multiple seconds worth of lag. It's possible that we could have wrapped around multiple times. Actually, with this, if it took less than 1/10 of a second, we would have wrapped all the way around. And so it wouldn't have worked. We would have hit that if again, and we would have wrapped all the way around, and then we wouldn't have gotten back to where we needed to be. We would just be here. And so this is going to lock it in place between 0 and 1. I suppose we probably could use a mod here, but I don't think that works with floats. Pretty sure that doesn't work with floats. So let's do this for declination as well. So if that's greater than 1, then we want to do our declination minus equals 2. And that's because it's from 1 to -1. So we're just subtracting the range here. Then we've got both of those. So the only other thing we need is a view model, which I'm just going to throw together really quick. No, I don't want PowerShell stuff. Why would I want PowerShell stuff? What would we call it? Data point view model. And so this is actually going to be public color. We'll call it the data point color, because we're going to have to actually create a reference or something to hold the actual color, because Unity's color objects don't exist here. And I'm not going to bring in Unity's library just to get color. That's a waste. And then we can actually just convert this back to float. So we'll do a float of our declination and a public float of our write ascension. Still don't like those names. Why did I switch to those? That was silly. Whatever. So now that we have that, let's build another type, our data point color. There we go. And that should be good. Then the only other thing we need is we actually need to set this. And it's going to be floats that we're going to use here. So Unity uses colors for, or floats for colors. And I think that's partially so it can support HDR. But the idea is 0 to 1 is going to be our color range. And if you go above that, I don't really know what happens. Might have to just take all of these things that I say I have no idea what happens and just make a video about going through all of them and exploring them and see what happens, see what breaks. But for now, let's just use RGB and our A, we can set to 1 for now. So by default, we'll just have it be white, and then you can set whatever you want and ignore everything else, and it should just work. So we have that. We have that. We have everything else. What we want then is to take our client and submit a message, which is going to be send message to server task async. So we can just do that, and we're going to need a string here that is going to be the message we want to send, which is going to be our encoded data point view model. So we're going to do just our message. And that is going to be a task, so it's actually just going to run asynchronously. If we wanted to wait for it, we could, and we probably should. But I'm kind of curious to see what will happen if I don't. So we're just going to leave off any sort of synchronization at all here, and just let it fly. And that's a mistake, but it's fine. I'm saying that way too much. It's not fine. Don't do this, but we're going to do it. Yeah, there. Ha. That wasn't very convincing, but okay. We're going to do a message here, and then what we need is we need a new data point view model. And we're actually going to call this the data point, and then make a message equal to that. So our data points look like that. We need to create a color equal to a new data point color. I'm just going to keep it white for now because it's already there. And then for write ascension, I'm just going to pass in our write ascension. And for declination, I'm just going to pass in our declination. And it's not going to like that because we're converting from a double to a float. So we'll stick in some casts because casts are great and everybody likes wearing them. And then that should be good. So our data point exists, and then our send message exists. Problem is, we aren't actually doing anything with this because our message is empty. So what we need some way to encode this into JSON. And so I'm going to go out to NuGet and grab Newtonsoft, which is here. We'll just install that quick. And so NuGet is sort of a package manager for .NET. It's got pretty much anything you would want on there. There's Twitter plugins and all sorts of stuff like that. Newtonsoft is a JSON parser and converter and all of that other fun stuff that pretty much works anywhere in .NET, and it's fairly fast and easy to use. So it's what I use for the most part. So all you have to do is do a JSON convert, and then you just do serialize object on a data point. So you just give it an object to serialize, and it will create a JSON object for you. And then I'm just going to do a log message quick. Console write line, sorry. And we're just going to say sending message of our message. So we just write the message we're going to send, and then we shoot it off somewhere, hopefully off to this endpoint, and it should work. So we're running here. So what I should be able to do is get over here, start this, and it should start. And then we start sending messages, and we start receiving messages, and then it starts lagging and bad stuff. Why did we only get 39? It's still sending them somewhere, but we seem to have stopped, and I'm not sure why. Well, it kind of worked. I don't actually know why that would have happened. Let's try restarting and see what happens. Because we should just create a server again, and since every single message we send creates a new client, we should just get new connections. At least that's the idea. We'll see if that works or not. Honestly, if it works, cool. If it doesn't, then, well, we'll learn something. So, or I could crash Unity. That's another option. Ooh, timeouts. Cool. Couldn't make a connection, or it's being refused. Yeah. So let's stop that for now. And then we'll go back here, restart it, open up Unity. I'm actually going to hide this canvas. Did we get an exception? Looks like nope. Visual Studio just decided it really wanted us to see these diagnostic tools. Cool, thank you. Oops, I didn't probably want to pause that. Regardless, we should be getting a bunch of messages. That should have done something. But again, we only read a certain number and then it stopped reading. So I wonder what's going on that's causing it to So we only read the message once, which makes me think let's see, where are we? We've got our name server stream. Like all of that. Could our, oops, opening audition. That's good. That's what I wanted to do. Good. Let's see, we've got our named client. I think this can go away. No. But even this doesn't do anything. That's not what we want. Regardless, we're going to take it out because it honestly isn't needed anymore. Actually, this entire canvas can be disabled. So let's actually do it this time because play mode. So we've got that. I'm going to close these because we're throwing a ton of exceptions. The reason we're throwing exceptions is because there's nothing to receive it. Our port is closed. So no connection could be made because the target machine actively refused it. And that's because, yeah, because I told it to. So we're actually going to do stuff with tasks here. So I'm going to grab the task, and then I'm going to do a task wait. And so this is just going to add, it's going to slow things down a little bit. It's going to wait for our message to be returned, which means we're going to receive it, and then we're going to actually wait for it to happen. So things are going to be slower, but hopefully more controlled, and we don't just flood this thing with messages, which means I can go back here and start this. And now if I look here, we should see this start. And send one message. Why are we pressing enter to continue? Oh, what? What is going on? Huh. That's odd. Interesting. I don't know what's going on, but the interesting thing is we're still receiving messages, and I stopped that. So I'm going to move this off to the side here. And if I hold this a bunch, we're getting hundreds of messages. Oh, found them. Cool. All right, so it is working ish. Kind of weird, but it is working. It's just odd. So I think this is a good place to end it, because what we have now is we have a way to actually send information from our console applications to Unity, which means we can actually consume data and send it there. The only thing we have to do is just use the common library, which is going to have all of those data objects and things like that. We're actually probably going to want to move Newtonsoft out of this one place and put it into our common, as well as this view model. And that way our applications or our plugins are only plugins. There's nothing that is required to actually make this work. You just include the common, and then you include your data, and then you go. So I think in the next video, what we're going to do is we're going to plug in Twitter, and we're going to plug in like some quick hashtags and see, and try to graph the information and see what we get. And hopefully it's interesting, and hopefully it works. Hopefully we don't get stuck like we did here again. But I think that's it for now. So if there's anything you guys want to see more of, let me know in the comments, or if there's something you didn't like, I'd like to hear that as well, so I can hopefully get rid of it or improve it or change it or whatever is required. So until next time, see you, Internet.